Our topic for today is how to solve quadratic equations by factoring using zero factor property. In dealing with equation, you can encounter this type of equation: 4x squared plus 4x plus 1 equals 0, or x squared minus 9 equals 0, or x minus 5x plus 6 equals 0. This is the quadratic equation, and it's in the form a x squared plus bx plus c equals 0. So a, b are the coefficients of x squared and x, and c is the constant. All are in the left side of the equation, and the right side of the equation is 0. So in a, b, and c are real numbers, and a must not be equal to 0. This a here must not be equal to 0, and if this a is equal to 0, then this is reduced to linear equation in one variable. This is called a quadratic equation in the second degree, or the second degree equation, because of this x squared. The exponent 2 here is this makes this in the second degree equation. So quadratic equation can be solved by 1, factoring; 2, by completing the square; and 3, the quadratic formula. Let's first deal with the factoring, but before factoring, we are going to deal with the zero factor property. It states that a and b are real numbers, and if you multiply a times b equals 0, so a must be 0 or b must be 0, or both are equal to 0. So for example, we have 2 times 0 equals 0. The first number also is 0 times a number, or 10, equals 0, or 0 times 0 is 0. So any number multiplied by 0 is 0. So solving quadratic equation by factoring, for example, we have x squared minus 7x plus 12 equals 0. So factoring, we had topics on factoring in the previous videos. We have topics on how to factor trinomial squares, and this is one of them. So this is not a perfect trinomial square, so you have to look for the factor that of 12, that when you add, it gives you the middle term 7x. So the possible factor of this must be both negative, since we have a positive in the last term and we have a negative in the middle term. So you can look for the factor which is, if you add, equals 7. So the possible factor is x minus 3 times x minus 4 equals 0. So we have, you add 3 and 4 is 7, both negative, and if you multiply negative 3 and negative 4, you can get positive 12. So now, using the zero factor property, set these two factors into 0. So x minus 3 equals 0 and x minus 4 equals 0. So simplifying the first, x minus 3, and we are going to transpose 3 to the right side of the equation, making it positive. So we have x sub 1. The first is noted with sub 1. First x is equals to 3, and second x is x sub 2 is equals to 4. We just transpose 4 to the right side, making it a positive or a plus. So x sub 1 is equals to 3, and x sub 2 is equals to 4. So go back to the original equation. You can substitute first. Let's try the 3. So 3 squared minus 3 squared minus 7 times 3 plus 12 equals 0. 3 squared is 9 and 7 times 3 is 21. So 9 minus 21 plus 12 is 9 minus 12 is negative 12 plus 12. So this is equals to 0 equals 0. Another example is x squared minus 30 equals 0. So you can look for the factor, which is here we have a negative in the last term, so it must be a negative and a positive. Then the middle term is negative, so the negative must be greater than the positive in absolute value, and they just differ in 1 by 1. So possible factor word is x plus 5 times x minus 6 equals 0. Then using the zero factor property, set these two into equal to 0. So x plus 5 is equals to 0 and x minus 6 equals 0. Transpose 5 to the right, so x of 1 equals negative 5, and transpose 6 to the right side, x of 2 equals 6. So two values of x here, one is negative 5 and the other is positive 6. So check, go back to the original equation and then substitute 5 first. We have negative 5 squared minus negative 5 minus 30 is equal to 0. This is positive 25 plus 5, minus minus becomes plus, so minus 30 equals 0. 25 plus 5 is 30, minus 30, 30 minus 30 is equals to 0 equals 0. You can also try the positive 6. The same result will yield the same result. So that's how we solve quadratic equation by factoring using the zero factor property. Please subscribe to my channel for next videos. Thank you very much.